Okay, so what if you could build a real, working piece of software, but without a single human engineer actually writing a line of code? I know, it sounds like something straight out of sci-fi, but that's precisely what a team at OpenAI decided to try. We're going to jump right into their wild 5-month experiment to see how they pulled it off and what it might mean for the future of building, well, everything.
So this was the big rule, the one non-negotiable they set for themselves right from the get-go. 0 lines of code written by human hands. Everything, and I mean everything, from the app's logic to its documentation, had to be generated by an AI agent.
And the result of this experiment? Well, over those 5 months, their AI agent, which they named Codex, cranked out about 1 million lines of code. Think about that, an entire complex code base built from a totally empty starting point, all by an AI.
Now, here's the real kicker. The team figures they did all of this in about 1/10 of the time it would have taken a traditional team of human engineers. That's not just a small improvement, that is a massive leap in development speed. And it really forces us to ask some pretty big questions about what a software engineer even does.
And that leads us right to the first major lesson from this whole thing. See, this wasn't about replacing humans. Not at all. It was about completely changing their job description. The new idea is actually pretty simple. Humans set the direction, and the AI agents do the heavy lifting.
The big shift here is what the work actually feels like. Instead of that tactical line-by-line grind of writing code and hunting down bugs, the job becomes way more strategic. The new focus is all about designing the environment where the AI can actually do good work. It's about specifying the intent, what you want to build, and then creating these feedback loops so the agent can learn and fix its own mistakes. You basically go from being a craftsman to being an architect.
This quote right here just nails it. The most valuable thing the engineers did wasn't writing code. It was unblocking the AI. So every time the agent got stuck, the team didn't just step in and fix the problem. They asked a much more powerful question. Okay, what system, what tool, or what piece of context is missing here that would have let the agent solve this all by itself? And the results of thinking that way? They're just staggering. With a tiny team of only 3 engineers guiding these agents, they were averaging 3.5 pull requests, that's basically code changes, per engineer every single day. That's a huge amount of output, and it just proves this model can be ridiculously productive.
But, this didn't just work perfectly from day one. One of the first huge problems they ran into was just figuring out how to give the AI the knowledge it needed for complex tasks without completely drowning it in information.
So their first instinct was to make this one giant file, like a 1,000-page instruction manual, and just feed it to the AI every single time it had a task. And it kind of seems logical, right? Just give it all the information it could possibly ever need. But it was a total failure, and for some really interesting reasons. First off, context is a limited resource for these AI models, so that huge manual was actually pushing out the important instructions for the actual task. The file also went out of date almost immediately. It basically became a graveyard of old rules. And, when you tell an AI that everything is important, it loses the ability to know what's actually important. So they came up with this much more elegant solution they called progressive disclosure. Instead of that giant, clunky manual, they gave the AI a map. It was a short, simple file that was like a table of contents, and it just pointed the agent to where it could find more detailed information if and when it actually needed it.
And that whole philosophy just grew from there. They decided the entire code base was the source of truth. They gave the AI senses, which meant it could directly interact with the app's user interface, it could read system logs, it could even check performance metrics. So the AI could suddenly see, test, and check its own work just like a human engineer would.
Now, this idea of the AI being able to see for itself connects directly to the next huge lesson they learned. I mean, if you have an AI writing 1 million lines of code at lightning speed, how do you keep the whole project from just falling into complete chaos? Well, the answer was architecture.
And this quote right here explains their whole philosophy. The team focused on enforcing invariants. These are the absolute, non-negotiable rules of the system, while giving the AI complete freedom on the implementation. They defined the what, and they let the agent figure out the how.
And they did this by building a really rigid architectural model with super strict rules. For example, code had to flow through a set series of layers in a very specific direction. They limited how different parts of the system were allowed to talk to each other. They even enforced things they called taste invariants, like how things should be named. And the best part? All of these rules were enforced by custom tools that the AI wrote for itself.
Now, for a human team, This level of rigidity might feel super frustrating, maybe even slow you down. But for an AI agent, these constraints are actually freeing. They create this predictable, stable playground where the agent can work really fast and safely, without accidentally breaking the whole application. They're not constraints, they're speed multipliers.
Okay, so you've got a new role for engineers, a smart way to give the AI context, and a solid architecture to keep it all in check. So what does that all add up to? Well, it adds up to an absolutely incredible level of autonomy.
And this is where things get truly mind-blowing. By the end of this 5-month experiment, the agent could handle an entire workflow all on its own. You could give it a single sentence about a bug, and it would go in, check the code, reproduce the bug, and even record a video of the bug happening. Then, it would go write a fix, record another video proving the fix worked, and then open a pull request for a human to review.
But of course, full autonomy created a totally new kind of problem, one they started calling AI slop. See, the agent was fantastic at replicating existing patterns in the code, but that included the bad patterns too. And over time, this led to this gradual decay in the overall quality of the code.
Their solution to this was just brilliant. They basically created a system of garbage collection for code. They defined a set of golden principles for what good code should look like, and then they unleashed other automated agents whose only job was to constantly scan the codebase looking for any of that AI slop, and when they found some, they would automatically open a pull request to fix it, essentially acting like a robotic cleanup crew for technical debt.
So, let's just quickly recap this incredible 5-month sprint. Back in August, it all started with nothing but an empty folder. By October, the team was wrestling with that big context problem. The huge breakthrough came in December, with that map, not manual idea. And by January, they had an AI agent that could do real end-to-end autonomous work.
So the biggest takeaway here is pretty profound. The hardest part of software engineering in this new world isn't actually writing the code anymore. It's designing the systems that let the AI write the code. It's about building the environment, the feedback loops, and the control systems. It's like building the scaffolding that allows for this massive AI-driven development to happen safely and at scale.
And all of this leaves us with a really fascinating question to think about. I mean, we have spent decades focused on optimizing how humans write code. But this experiment gives us a real peek into a future where that's just not the main event anymore. So what does that mean for technology, for innovation, for the very act of building things? What happens to the world of software when the coders are no longer the ones writing the code?